Hey friends, I'm Rashmika welcoming you to Keep Calm and Love Maths. So today we will discuss about some problems related to composite functions. Already we have discussed what is composite functions, and we have also done with some theorems related to composite functions. So today we will start from the questions related to composite functions. So the first question is, let A, B, and C are two sets where A equal 1, 2, 3, 4, B equal A, B, C, D, and C equal L, M, N. If two functions f from A to B and g from B to C are defined by f is the set 1A, 2C, 3B, 4A, and G is the set AL, BL, CM, and DM. Find G naught F and F naught G whichever exists. So we are given three sets A, B, and C, and we are given two functions f and g. F goes from A to B, G goes from B to C. Then we need to check whether G naught F exists or F naught G exists. Whatever exists, we need to find the set also, find the composite function also. So the solution is, we all know that to check existing of a composite function, we need to check whether range of f is subset of domain of Z. Whenever range of f is subset of domain of Z, then we get the composite function G naught f existing. And when range of Z is subset of domain of f, then we will get the composite function f naught G. So this is the key points to check existivity of composite functions. Whenever range of f will be the subset of domain of Z, then we get G naught f existing. In the other hand, whenever range of f is subset of domain of f, range of Z is subset of domain of f, then f naught G exists. So here we will apply this to show whether G naught f and f naught G exist. Range of f is the set of elements from the second elements of f. A, C, B, A, that means A, B, C. And domain of f is 1, 2, 3, 4. Similarly, if we see Z, then we will get domain of Z as A, B, C, D. And range of Z as L, L, M, M. That means Ln. So, when range of f is subset of domain of Z, when range of f will be the subset of domain of Z, then we will get G naught f exists. Here we can see here ABC, set ABC is the subset of set ABCD. Since ABC is the subset of set ABCD, or we can say range of f the subset of domain of Z. Therefore, the composite function Z naught F exists. Find Z naught F and F naught G whichever exist. Here we can see here Z naught F exists, and also we need to find whatever the elements in Z naught F. So the next part will be whether Z naught F is what? Z naught F, the composite function Z naught F consists of the elements. Now we can see this is the composite function which goes from the set A to C. Because F goes from A to B and G goes from B to C, then their composite function Z naught F always goes from A to C. Now, here the domain is A and the elements in A are 1, 2, 3, 4. So we can check Z naught F of the element 1 is equal. Now by definition, Z naught F of some x equals Z of fx. So here Z naught F of 1 equals Z of F of 1. Now what is F of 1? F of 1 is nothing but the image of the element 1 in the set A. What is the image of this element 1? Now we have given the function f as that ordered pair 1a, that means 1 has the image A, or we can say f of 1 equal A. Similarly, f of 2 equals C. So here f of 1 equal A. Again, what is g of A? Since we are given the function g as the ordered pair AL, BL, CM and DM, this means this element has the image L, B has image L, C has image M and D has image M. Or G of A equal L, G of B equal L, similarly the others also. So here G of A will be equal to L. That means Z naught F of the element 1 will be the element equal L. Since the set A contains 4 elements 1, 2, 3 and 4, we have done only with 1. So we need to proceed with these elements also. Now Z naught F of 2 equal Z of F of 2. And F of 2 is nothing but C. That means Z of C. Again, G of C is nothing but M. Similarly, G of F of 3 equals G of F of 3. As given, F of 3 will be B. That means G of B. Again, G of B equals L. The last one, G of F of 4 equals what? G of F of 4 equals G of F of 4. And F of 4 is nothing but A. That means G of A. Again, A has the image L. Therefore, G of A equals L. Therefore, in this question, G naught F exists and G naught F contains the elements L and N. So we can write the composite function G naught F as 1 is related to L, 1L 2m 3l lastly 4. So this is the composite function g naught f existing here. Now the second part, we need to check whether f naught g exists or not. So for that, to check f naught g, we need to find range of z is subset of domain of f. When whether range of z is subset of domain of f or not. Domain of f or not, we need to check. Here range of z is ln. Here and domain of f is the set consisting of 1, 2, 3 and 4. Here we can say obviously the set Ln cannot be the subset of the set 1, 2, 3, 4. So this condition not satisfies. Since range of Z is not a subset of domain of F, therefore the composite function f naught z does not exist here. So this is the question. We need to check whether these two composite functions exist or not. So we can see z naught f exists, but the function f naught z never exists here. So this is done. Now the other questions, question number 2 and question number 3 are here. Question number 2 is, if f of x equal 1 by x and g of x equal 0, so that f naught g is not defined. If we have f of x equal 1 by x and g of x equal 0, then we need to show that f naught g is not. So let's go to the solution. We have f of x equal 1 by x. F of x equal 1 by x and g of x equal 0. Now if we suppose that f naught g is the composite function containing the elements like suppose x, then composite function f of g of any element x will be, by definition of composite function, f of gx. Again, since we are given in the question g of x equals 0, then it will be f of 0. Now, already we have that f of x equal 1 by x, but we cannot find f of 0. If we take x as 0, then f of 0 will be 1 by 0, but 1 by 0 cannot be defined. It is known always, because you already know that 1 by 0 it cannot be defined. So f of 0 we cannot define in this question. Therefore, the composite function f naught z we cannot define here. So this is not defined. Since this is not defined, that means f naught z is not defined. F naught z is not defined. So this question is very simple and it was very easy, because we already define that f of x equal 1 by x and g of x equals 0, then f naught g of x is always be not defined. So this is done. Now the question number 3. If a function f from R to R is defined by f of x equal x square plus 2 and another function z from R minus 1 to R defined by z of x equal x by x minus 1, then find f naught z of any element x and z naught f of any element x. Here the domain is R minus 1. It is because whenever we take this x equals 1, that means z of 1 will be the 1 by 1 minus 1, 1 by 0, and always you know that 1 by 0 is not defined. Therefore, we cannot take the element 1 in the domain. So, the domain is R minus 1. So, the solution is f naught z of x is nothing but f of z of x, and z of x is defined as x by x minus 1. Again, what will be the value of f of this? If we take this whole x by x minus 1 as capital A, then by definition of this f of x, it will be a square plus 2. So here a square plus 2, but a is nothing but this element. Therefore, x by x minus 1 square plus 2. Now we simplify this, then get x square by x minus 1 whole square plus 2. Taking LCM of this, x minus 1 square, here x square plus 2 into this part, that means 2x square, x minus 1 whole square. If we simplify, we get x square minus 2x plus 1 square, x square minus 2x, but we multiply 2 here, so minus 4x plus 2. Finally, we can get 2 plus 1, 3x square minus 4x plus 2 divided by x minus 1 whole square. So, the composite function f naught z of x will be the 3x square minus 4x plus 2 divided by x minus 1 whole square. So, the next part, z naught f of x, for that, z naught f of x. By definition of composite function, this will be equal to z of f of x. Since we have f of x equal x square plus 2, now again z of any element, it was x by x minus 1. We have z of x equal x by x minus 1. So if we take x square plus 2 as capital X, then it will be x by x minus 1, but capital X is nothing but x square plus 2 divided by x square plus 2 minus 1. Now finally 2 minus 1 plus 1, x square plus 1. So z naught f of x, by definition g of f of x, and applying the definitions of f and g in the question, we finally get this this part equals x square plus 2 divided by x square plus 1. So this is the solution f naught g of x, and those are g naught f of x is this, and f naught g of x is 3x squared minus 4x plus 2 by x minus 1 whole square. This is the question. So this is done. So that's all about this class. What we have learned today. So we have done some problems of composite functions, and also some of the questions related to this function I have left today, but I will be discussing in the next video. And if you like my videos, do subscribe to my channel and press the bell icon. Thank you for watching.